our webinar slash live demo workshop today with Ali Spittle. We're going to let some people file in from the waiting room right now, but in the meantime, I just wanted to make a few announcements. First, this is being recorded. We've had some questions. If you're not able to stay for the whole 2 hours, or you want to come back and review this, it will be recorded. If you registered for the Zoom event, it'll be sent to the email that you used to register. You can also go watch it immediately after it's done on Twitter or YouTube, where we're live streaming it as well. And second, Ali will be doing a lot of, like I said, a lot of demo, a lot of live coding. And so if you have questions or want to engage and interact with her, she will be doing some Q&A and answering your questions throughout. So please make sure to drop any questions that you have in the chat box, and she'll be looking at that throughout the event. And so before we start, I just want to thank Ali again for taking the time to do this with us. Ali is a senior developer advocate on the AWS Amplify team, and she's a respected voice in the developer community. She also runs WeLearnCode.com, which has a lot of awesome resources, tutorials, and guides for beginning developers. So make sure you go check that out as well after this event is up. And so with that, Ali, I'm excited to have you here, and the time is all yours.
Awesome. Well, thank you so much. I'm so excited about this topic. So I started off my career as a true backend developer. I only wrote Python for the first couple of years of my career and had the title DevOps engineer, and then eventually transitioned more into the front end side. And now I work at AWS, where I specifically work for front end developers, but a lot of what I do is still writing backend code. And so I want to give this workshop that's kind of a crash course on a bunch of topics that I think will be helpful for you, at least to have context on as a front-end developer. So I'm going to be teaching a lot of different concepts. So feel free to ask me questions at any time if you want me to slow down, go back to something or anything like that. I do have a lot of demos throughout. Some concepts are not going to get demos, and I'm just going to talk about them at a high level. These are mostly the things that I think are a little bit less must-know topics. So that's a little bit about what we're going to be chatting about. Thanks for the intro. I'm Ali. I am a senior developer advocate. I also lead and manage the developer advocacy team. So I am A Spittle pretty much everywhere on social media. So if you want to stay in touch with me after this, you can reach out to me there on Dev2 there, Twitter, Instagram, wherever. That's what I go by. And then on top of that, I have my own site, WeLearnCode.com, and also a podcast with some of my friends called the Ladybug Podcast, which is really fun. So our goals for today are to chat about cloud and backend development concepts. We're going to be building an app backend using AWS Amplify. In fact, we're going to be building the same app backend quite a few times with different technology stacks, so you can see a little bit of what goes into different ways of doing the same thing. And the goal is to walk away a little bit more full stack than before. And maybe you won't be a full stack developer, but you'll at least be able to speak to those backend developers a little bit better, which I think is a really important thing, because being an engineer is a lot of communicating with people. So first, let's chat about what the cloud is. And to put it really simply, it's the on-demand availability of resources. So you may have used iCloud as a non-technical user, or Google Drive, or any of these things, and they're cloud providers. But many companies also use the cloud for their server infrastructure. And to take a step back, a server is essentially just a fancy computer that provides functionality for other programs or devices. And they handle serving web pages, applications via the request response cycle. So you request a website and it responds with something. Even this Google Docs presentation, you can type in the link, go to it, that's making a request to Google Docs and giving you the response. So historically, you would have a data center to store all of these servers. They're essentially just fancy computers. And maybe at a smaller company, you would have a server rack. This is how I started my career. I had my own servers that I was deploying things to, and they were in the same room that I was programming in. That's awesome, but a lot of times there are some benefits of using the cloud, where you're essentially buying a piece of somebody else's server, or you're renting a portion of that server. You could even rent the whole thing as well. And you can add another server in a matter of hours or minutes instead of having to wait for a new server to ship and to install it and all that. So it's much easier to grow and scale. And so some of the benefits of the cloud are that you pay for what you use. So if you have 50 servers, in a office, you have to pay for all of those, no matter how much you use. But a lot of cloud technologies will allow you to scale to what you actually end up needing to use. So if you use a tiny amount of server space, then you only have to pay for that. If you have a huge amount of server space, then you pay for that instead. You also don't need to pay for the maintenance of physical data centers. You don't need to have people working there in order to set them up or work on them or anything like that. And then you can also go global in minutes. So instead of having to install data centers around the world to get lower latency, you can just do this that way. So it's usually less expensive. There's a whole AWS white paper on the benefits of the cloud. If you Google it, you'll find it pretty easily. And that is where a lot of this is coming from. There's some more on there, but these I think are the most relevant. So we're going to be mostly using AWS today. AWS is a cloud provider. It's broken into a bunch of services. So there are 200 of them, which can be a little bit tough to navigate and a little bit intimidating for people to start out with AWS. But we're going to be using Amplify, which is a service that allows you to access these other services without having to know them in too much depth. So we'll talk about those services, but you can kind of provision them without having to have too much in-depth knowledge about them. Some examples would be EC2, which would allow you to have a virtual server in the cloud, S3, which we're going to be using today, which allows you to host static files. There's also Serverless, which is AWS Lambda. We'll be talking quite a bit about that in the future today. And it allows you to not even think about the server at all, which is really nice. You don't have to do all that manual configuration or anything like that. So the first step is to create an AWS account. So you can go to aws.amazon.com if you want to follow along. And then you can create an account. You can include, make sure if you're going to be provisioning resources or whatever that you include a billing account, and make sure to read and accept the customer agreement and verify your phone number. So that's the first step if you want to get started with AWS. You don't need to follow along with this workshop. It's going to be a lot of me talking, but if you want to, you can go ahead and do that. The next thing that I want to talk about is creating a billing alarm. And so this is important so that you get an email if your charges ever go above a certain amount. And so if you go to aws.amazon.com/free, this has the information about the free tier. So the first 12 months that you have an AWS account, you get a lot of these services for free, or at least to a certain amount. So with Lambda, for example, you get 1 million free requests per month. Or with Amazon S3, you get 5 gigabytes per month for free. But a lot of times you want to make sure that you are not going to rack up a bunch of bills without knowing about it. So I'm going to go ahead and then sign into my account. It's going to ask me to sign in. And then from here, we're going to navigate to CloudWatch. So the management console within AWS is going to allow you to view all of these different services, the 200 or whatever it's at now. It's always changing. In fact, there's a new service this week, so maybe it's even more than I thought. So I'm going to go to CloudWatch from here. And if it doesn't show up on the homepage for you, you can type it in here as well. And then click that to get to this page. And then what we're going to do is we're going to navigate to alarms. So I have one billing alarm already set up, but I'm going to create another one. So select metric, and then you can type in billing, wait. I think I'm doing this wrong. So I already have a billing alarm set up, so maybe that's why, but this is going to show me my estimated charges for the month, which you can see is not very high. I have a billing alarm set up so that once I get to $10 a month, I'll get an email. So if I am ever going to get charged more than $10, I know about it. You can change that amount as well. Do like edit. You can also do anomaly detection. So if it spikes above a certain amount, I don't think I've ever gotten more than $2 as my billing amount for the month. So that's why it's saying that if I got more than $2 for the month, then that would be an anomaly. So I'm making these Amplify apps all day, every day, and it's never costed me more than $2 a month. So that's kind of nice. But yeah, you can say whenever the estimated charge is greater than 10, for example, then it will send you an email. And so that's nice to know that if you're going to have any unexpected charges, you will know about it. I've never actually gotten the billing alarm to email me again. I've only had charges of like $2 a month. And I think that was for domain names too. So now you have an AWS account set up and you have a billing alarm so that you know if any charges are going to occur. The next thing is IAM. So IAM is AWS Identity and Access Management, and it helps you control access to AWS resources. So if you go to IAM, within here, you can manage access to AWS resources. And so there's this concept of least privilege principle, and that is that you want to give the least amount of access as possible, only access what is necessary to each account. So you normally don't want to use your root user for much. So the root user is that user that you created when you made an AWS account. You normally want to create an IAM user under that has certain permissions enabled. So you can go to IAM and then click on users, and then you can create add user. You can create a username for them. And then you can give them programmatic access and AWS Management Console access. The AWS Management Console access is going to give you access to this interface. Using that account, the programmatic one will allow you to access it through your code. So through an API or the command line interface or the software development kit, that's what that's going to allow, whereas this is going to allow access to this website. So you can create a custom password and then set up permissions for them. So you can create an admin so that they have administrator access. That's probably what I would recommend doing, but you can also go in here and you can search for different roles. So administrator access just for Amplify, for example. And if you click on this to see what is in the policy, you can see that Amplify has access to list, read, write, for example, or the admin UI has full access. So if you just want to limit your AWS IAM user to have access to Amplify, you can do that as well. So now we have created an AWS account. We've talked a little bit about the least privilege policy and billing alarms. Now let's talk a little bit about what we're here to learn about, which is backend development. And so some of the tough parts of backend development are scaling. So how do you scale from 0 users to 100 users to 1,000 users to 1,000,000 users to more than that? And that's a really, really tricky piece of the puzzle. And there's two types of scaling, horizontal and vertical scaling. So vertical scaling is when you add additional resources to a server. So you have one server, you add more CPU to it or add more memory to it or anything along those lines. Horizontal scaling is when you add another server. So then you have multiple servers for the same system. Another difficult piece is system design. And this plays into that scaling of how do you design a system that will be able to keep scaling and be able to do all the things that you need it to do. And then another piece is picking the right tool for the job. And here's the thing is that there's no absolute right answer to this at all. There's usually just trade-offs. So there's benefits and cons to every single solution that you're going to choose. So we're going to talk about some of those pros and cons to different solutions today, but again, there's no right answer. There's just a bunch of different answers with pros and cons to them. I also want to remind you that you can ask questions no matter what platform you're on. I'm going to be deploying things throughout this, and so I'll have a couple of minutes while things are being provisioned in the cloud that I can very much answer your questions. That's probably when I'll mostly do that. So the first thing that I'm going to dive into is data. So there's some considerations for the data for your application. So NoSQL versus SQL, the types of NoSQL databases, how to model your data, and then also offline and online availability. This is especially important for your front-end and mobile developers because a lot of times you're going to want to have on-device storage and off-device storage so that many users can have access to the same data. So let's talk about first NoSQL versus SQL. So SQL is structured query language, and you may hear this also as SQL instead of SQL. It's really funny. I was on a panel a couple of weeks ago about NoSQL versus SQL, and half the panelists were calling it SQL and half were calling it SQL. So I don't think there's a right answer here. I think it's just different people calling it different things. So SQL stands for structured query language, and normally when you use SQL, you have what's called a relational database. So you have multiple tables, and then you have data that connects to other rows in other tables using something called a join. And on the next slide, we're going to look a little bit deeper into what a join is. Then a NoSQL database stands for not just SQL. So it's not an anti-SQL thing or anything like that. It just goes beyond SQL. And this is a catch-all for every other type of database, and there's generally no joins. We're going to dive deeper into some examples of NoSQL databases too. So this is a join. So normally with a SQL database, you want to normalize your data. And what normalizing your data means is that you don't want to have repeat data across your tables. So you're trying to be as dry as possible, to use a programming term. So for example, if we're building a shopping cart, we have customers, we have items, and then we have the logs of when somebody bought something and what they bought. So for example, this table could be our item or our shopping event database. So this is going to say that somebody bought something at May 23rd at 1:23 in the morning. We've all got those early in the morning buys sometimes, or really late at night. So this is going to say that it's completed, which means that it was sent to somebody. And then each one has an item ID. So instead of saying that the person bought a t-shirt directly within this table, it's instead going to point to a different table and say that we bought a t-shirt. So this item ID aligns with this t-shirt ID right here. And then the same thing is true for number 2, which is slippers. So both this person and this person, or this checkout experience and this checkout experience, both of them bought slippers. And this last person, they bought a phone. And so we use this item ID to point to each one of these. And that saves us some memory in that database. We don't need to rewrite or have the information for teddy bear over and over again. And in a real database, you'd probably have a description of that item, you'd have the price for that item, and all of that. So instead of it just being one column, you'd have multiple. And then the same thing for customer ID. So for example, first is customer 3, who's NSYNC. NSYNC bought something again on June 1st as well. And then Cher bought slippers, and then Britney Spears bought a phone. So here's how we line up data within a SQL database. We have multiple tables, and then those tables are related to each other through IDs. And then we join the data onto each other. And you can imagine that this gets pretty computationally expensive as this scales. So if we need to figure out what item each person in this table But then we have to join all of those instances onto items and onto customers, and it's a little bit difficult to scale. So there are some really good benefits of SQL. First, that it's standardized, it's understandable, and everything is relational, so that data is normalized. Usually it takes a little bit less data to actually store that information, whereas NoSQL can be super low latency because you don't need to do that join process usually. And it tends to be a little bit better for hyperscale or for really large amounts of data. The drawback here is that it's a little bit of the Wild West, where each NoSQL database works a little bit differently than the other ones. There's also different categories of NoSQL databases, and so that gets a little bit confusing. So usually NoSQL is a little bit better for hyperscale, whereas SQL can be a little bit easier for beginners because everything is standardized and understandable. And also you can store a little bit less data since that data is normalized. And also, so SQL servers, you can normally scale them more vertically. So that's adding more CPU or memory to that one database, whereas NoSQL usually can be a little bit better for that horizontal scaling where you add multiple servers to the same system. So there are different types of NoSQL databases. There's different families of them. So the first one is a key value store, and each item is stored with a key and a value, like an object in JavaScript. So in an object in JavaScript, you'd have a key with a value attached to it. So an example of this would be a Redis database. That is a key value store. There's also graph stores, which focus on relationships. This is really good for social media sites like Facebook, for example, where you have these relationships between different people. And so Neo4j is an example of a graph store. There are column stores, and these are sets of columns. These are really good for analytics, where you're querying based on columns instead of rows. Normally, you're querying on rows within a SQL database. Column stores, you'd be querying on the column instead. So this is really good for getting aggregate numbers of sum of a column or something along those lines. Cassandra is an example of a column store. And there are document stores, which stores data in JSON or BSON or XML. BSON is a JSON that's in binary, essentially. So you can have document stores, and this is MongoDB. MongoDB is one of those. So those are some of the types of NoSQL databases, and these are the common families of them. What we're going to be talking about today is mostly DynamoDB. So Amazon DynamoDB is a serverless key value and document database, and it is highly scalable. So its main value proposition is that no matter how much data you have in it, your query speed is going to stay the same speed. So it's really optimized for those hyperscale type use cases. Amazon.com is built on top of it, for example. And so it's a serverless key value and document database. So it fits in both of those categories that we talked about on the last slide. It has a couple things. So a primary key is a very big concept within databases. And to go back to our join example, the order would be an example of a primary key. So each row in the database has a primary key associated to it. And that's a unique identifier so that you can have some sort of way to query or get just one of the items without conflicting with others. So it's a unique identifier. So within DynamoDB, you're going to have one of those. Another thing to think about with DynamoDB is that you normally want to model your data based off of your use cases. So how you're going to access that data is how you decide to make your schema. Another big thing is whether you want online and offline data, and in a lot of use cases, then you need to store the data both on the device and in the database. So you need to store the data in the browser or on the iPhone and in your database so that that data is cross-user. Some systems, this is increasingly important because the data loss would be devastating. So in medical systems, mining are two examples where losing data would be a really big deal. And so you really want to make sure that the offline data storage is there. So Then we get into the CAP theorem. And the CAP theorem states that with a distributed system, and you're getting a distributed system whenever you have offline and online data, because you at least have those two systems, the phone and then the database on your database server. So you can only have two out of the three: partition tolerance, consistency, and availability. Partition tolerance means that a system continues to run if there are outages. And with an offline system, we have already said that we need partition tolerance. Consistency means that with every request, you get a response on success or failure. And consistency means, sorry, I messed these two up. Consistency means that all replications have the same data at the same time. So both the offline system and the online system always have the same data, which we normally cannot guarantee with an online offline system. And then availability. So availability means that each request gets a response of success or failure no matter what. So you're always going to get an error message or get the data back. So you can only have two out of the three, according to the CAP theorem for distributed systems. And so normally with an online offline system, you need partition tolerance and you want availability. And so consistency becomes the one sacrificed. And normally you sacrifice that consistency for eventual consistency. Eventual consistency says that at some point the systems will be consistent. So both the offline database and the online database will have the same data at some point, but not necessarily immediately. And you'll hear that a lot with different cloud services, that there's eventual consistency within it. So that's the one that's most often sacrificed according to this CAP theorem. So we're going to use AWS Amplify DataStore for one of our demos in a little bit. And so this is going to store the data both in IndexedDB, which is an in-browser database. It has more storage availability than local storage, which you may have used before. And it also is asynchronous, which is a little bit nice for that JavaScript code too. And DynamoDB, which is that database that we talked about. And there's no extra work for the developer. It's just going to sync the data automatically for you. So now we're going to transition into talking about API creation, but I want to look through the comments real quick. So the first one is, what is a CDN? So CDN is a content delivery network. It's going to allow you to kind of do what it says, deliver content to your users. We won't go too deep on that today, but you could definitely look into that more as well. Another question is, what is ECS in AWS? And that is a container service. We'll talk a little bit about containers, but kind of at a high level. I'm actually doing a Twitter space on containers on Friday at noon Eastern time. So if you want to hear a bunch of pros on containers talking about them, come to that event. That probably will give you a better answer on those. And then the next question is, could you take an action on an alarm, like stop allowing requests if it's going to cost more than $10? So there's no way to automatically do that, but what you could do is when you get that billing alarm, you could then shut down the service or the provider for however long you want to. And then the next one, if a front-end engineer wants to make a shift to back-end engineering role, how do we do that? How do we establish our back-end development skills to showcase during an interview? And my answer to that would be to build things and build out a portfolio, show them that you have those skills. Another great thing to do is write blog posts so that you're demonstrating your knowledge to the public and showing off those skills that you have to future employers. The best way to really learn something is to teach somebody else too. So I would highly recommend that, whether it's through blog posts or YouTube videos or however you're comfortable. The last one is, why would somebody choose DynamoDB over other databases? And I think I tried to answer that a little bit with my different types of databases, but the first thing is that it's serverless, which we'll get into in a little bit. So that means that you don't have to do the database management yourself. It's managed for you. So it'll scale as needed, especially if you have auto scaling turned on. And then the other thing is that it is optimized for hyperscale. So that means that queries are still going to be really efficient, even if you have a ton of data within it. Another thing that's really nice about it is that since it's built for serverless systems, it's going to allow more connections to it. So with a lot of SQL databases, you're limited to having 100 connections to that database at one time, which works pretty well for a SQL database because you normally wouldn't have that many as is. But if you're using a serverless model, which we'll talk a little bit in the future, you need to have multiple connections going at once to that database, and you can't guarantee that it's going to be under 100 at any time. So you're going to need to allow those additional connections, and something like DynamoDB will allow that as well. So I hope that that answered those questions, but I'll definitely take more throughout too. So if you have them, please ask them and I will try to answer them as best that I can. Though AWS is such a deep world, and I know my little piece of AWS really well, but there's so many other worlds within it that I am not the best person to ask, though I can put you in touch with the people who are the right people to ask. So now we're going to start talking about API creation. So we've talked about data and where to store that data, but now we need to talk about how to actually access that data. And normally you're not going to want to build a connection directly to the database. That would lead to a lot of security issues. And so we want to build an API on top of that data. An API, you probably know this if you're a front-end developer, but application programming interface, it allows you to make a request to get that data essentially. So some considerations that play into this is server versus serverless, GraphQL versus REST, and should you use a container? So serverless versus a server. So serverless decreases the administrative overhead and cuts some server costs. And for me, as somebody who mostly focuses on the front end, this is a much easier way of deploying something than something that requires a full server. Doing the server configuration and scaling and all that can be a ton of work. And using a serverless model makes it so that it scales for you. You don't need to worry about that yourself. There are some downsides that come with that, though, and the fact that it's less configurable because it does a lot of the work for you. And there can also be this thing called a cold start, which increases latency. So since it's auto scaling, behind the scenes, it needs to allocate additional server space once you go past the server space that was already allocated to that function. And so sometimes this is going to make it so that it takes a little bit for that additional server space to be allocated. And then you have a little bit of time or latency until that actually kicks in. It can also be potentially a learning curve if you've been working with a serverful model. If you're going to serverless, then you need to learn a little bit more. It's a little bit simpler, but if you are coming from this world and have been doing it for a long time, it can have a little bit of a learning curve. So there are different categories within serverless as well. So there are functions as a service. So if you've heard of AWS Lambda, that would be functions as a service. So you essentially have a function that's deployed. You use an event-based architecture to trigger that function. So an event happens and then that function runs. Really similar to an event within front-end programming where somebody clicks a button and some function in your JavaScript code runs. This is a similar thing, though a lot of times these are triggered by other things. So you ping a URL that runs the Lambda function, or you have it running on a schedule, so it triggers every X minutes or something along those lines. So that's functions as a service. That's probably what you think of most when you hear the term serverless, but there's also serverless databases and serverless containers, and these allow you to run these services without needing to worry too much about the scaling or anything like that. So DynamoDB, Amazon Aurora, Firebase, those are all serverless databases. Amazon Fargate would be an example of a serverless container. And then serverful is when you have a server, like it sounds like, and you have to provision that yourself. So if you've heard of EC2 or Elastic Beanstalk, those are server full. We won't talk about them too much today. We're going to focus on serverless mostly, but just in case you've heard these things before, these are server full services. So now let's transition to chatting about REST versus GraphQL. And this is an interesting topic. REST APIs have been the de facto standard for the past decade plus in development. They are tried, tested, they've been through the ringer. People have been making them for a long time, and people are pretty used to them. But the real downside to REST APIs is that a new endpoint needs to be created if the front-end engineer needs the data in a different format, if they need different data, or they need more data. So for example, if the thing that the front-end developer needs changes, then the API needs to be rewritten to match that format. This can put a big load on separate front-end and back-end teams. So if you are a full stack developer and you're building the API yourself and building the front end yourself, then that can work great. But if it's two separate teams and you have to wait a bunch of time for the back end developers to write that new endpoint, that can be pretty tricky. And so that's the downside with REST APIs. But we're going to build one right now. So we're going to use AWS Lambda, which is a serverless service. I like that, the alliteration of serverless service that allows you to run code without provisioning or managing servers. So you can push your code or upload it to a zip file or a container, and Lambda will run it. And it's this event-based architecture where some event triggers the function to run. We're going to use AWS API Gateway on top of that. We're going to create an API and route to it. And then we're going to make it so that when that person hits that URL, they trigger API Gateway. So let's build. So what we're going to do is I have some code actually pre-written. I pre-wrote the front end because this was the back end workshop. I didn't want to rehash the front end. So I built out a Instagram type clone. And it has a timeline, it has Instagram cards, there's a comment form, a comment list, and then there is some create user, a timeline, and then a user list. So if I go to my site, it's like localhost 3000. And my code is up, by the way, at this link, and I will also send out the link to the slides afterwards as well. And I also see a question about creating a serverless GraphQL API in AWS, and that's actually the next thing that we're going to do. So we're going to create a REST API first and then a GraphQL API. So don't worry, it's coming. So this is my app that I have pre-built with React. If I go to localhost 3000, then you can see that this is the bare bones app that I have built out. I also have a front end tutorial if anybody wants that on how to create this front end, but it's nothing overly fancy. So what I'm going to do is I'm going to build a REST API that allows us to create a new user and then list my users on this page. So I'm going to go into my terminal. And I have the AWS Amplify command line interface installed. You can do that pretty easily. It's like npm install AWS CLI or Amplify CLI. I can link to those instructions as well. We'll actually do that in the future as well. So I'm going to run Amplify add storage. Actually, before that, I'm going to run Amplify init. So Amplify init is going to initialize Amplify for my project. So you can choose a name for your project and then click enter. I'm going to also pick an AWS profile, which will be a Spittle, and you can add a new one if you want as well. And that will initialize my project. Here's the instructions for installing the Amplify command line interface that I just did. So I just answered that in the chat, but it's this link right here. And then I also am going to send an article about decreasing cold starts as well. It's a pretty good article about that. Cool. So now Amplify is initialized for my project, and I'm going to add storage. So I'm going to add a NoSQL database. So this is going to add DynamoDB to my project. You could also do content instead, and we're actually going to do that down the road within this presentation. So NoSQL database, and then you can pick a name for it. So I'm going to call it user profiles. And then I'll call this user profiles as well. Really original, I know. And then how would I like to name my column? My first one is going to be ID, which will be a string. I'll use what's called a UUID, which is a random hash that's generated. I'll add another column, which is going to be my username, which will be a string. And then I'll add profile pic, which will also be a string. So I'm just going to do these three for this demo. We're going to be doing two APIs that are GraphQL that will be more fleshed out, but just for this, I'm going to focus on the users and that's it. And then I don't need to add any more columns. And I need to choose a partition key. So this is going to be like my primary key. I'll call it ID. I don't want to add a sort table. I don't want to add a global secondary index. And no Lambda trigger. I realize it's kind of going off the page, but I just put N in there a bunch of times. And then the next thing that I'm going to do is I'm going to add an API. So I added my data storage, and now I need to add my API. And I'm going to create a REST API. Again, I'm going to come back and do a REST API or a GraphQL API down the road. I'm going to call it user profiles. I'm going to make my path users. Then I'm going to create a new Lambda function. Also going to call this user profiles, use Node.js. I'll do hello world, do yes. Yes, I want to add my storage, so I'm going to press space on that one. And I want full cred, create, read, update, delete. I don't want to invoke it on a recurring schedule, but if you have a question about what cron jobs are, that's what a cron job is, where you recur something on a schedule. So every hour you run the same task or something along those lines. So if you wanted to do that, you could do that, but I'm not going to for this app. And no Lambda layers. I do want to open it up. This is just going to open this in VS Code for me or Visual Studio Code. Okay, so that popped this function up for me. And I'm going to change actually into this directory. So you can see that when I ran first Amplify init, it created this Amplify directory. It also created this AWS exports.js, which has the path to my API, for example, and all of that. And then when I ran Amplify add storage, it added this storage directory here with information about my database. And then when I did Amplify add API, it added this function for me. So within that function, there's source, and then there is event.json and index.js. So I'm going to actually cd into this directory. Okay, so cd amplify backend function user profiles source right there. And then I'm going to install the libraries that I need. So npm I AWS SDK, and UUID. So UUID is going to allow me to add a unique identifier, which will be the primary key or the ID for each user. And then the AWS SDK is the AWS software development kit. This is going to allow me to access these AWS resources within my Lambda function. So I will run that. And it installed it. And now I need to actually write my code. So bear with me. I'm going to be live coding and I'll hopefully walk you through this. So const AWS equals require the AWS SDK. Const UUID equals require UUID. And I'm going to connect to my AWS region. So AWS has this concept of regions, and that's essentially where the data center is located that you're connecting to. And so in my case, that's normally US East 2 because I'm in the Midwest of the United States in Chicago, but you essentially just want to pick the one that's closest to you, but they're also going to store it as an environmental variable for you. So if you set it up when you set up your AWS account or your IAM user, then it's going to use that. So I'm going to say user.update region process .env.table region. It also gives me this comment with the different variables that are there. So actually, I'm going to try region. I think that would work too. Okay. Then I'm going to say const DynamoDB. So new aws.dynamodb.document client. This is going to allow me to interact with DynamoDB. So I'm going to get my table name. So when I did Amplify add storage, I had to add a table name for my database. Normally you would store things in either multiple tables or in one table. There's this idea for DynamoDB specifically of doing single table design that really becomes more important if you're creating like a massive application. It's fine to use multiple tables within a smaller one. So that's what we're mostly going to be doing. But right now we only have one table anyways, which is pretty nice. So let table name equal process.env.storage user profs profiles name. So again, that was right here. I'm actually going to copy and paste it in case I spelled it wrong. I did not. So if you've ever used Node.js before, process.env is how you get environmental variables. Environmental variables are what they sound like, variables stored to your environment. They're usually things that you don't want to push to something like GitHub because they're maybe your secret keys, they're your API keys, things that if a hacker got access to would be pretty bad. In this case, getting the name of our table is not the end of the world by any means, but it makes it so that if I change the name of my table down the road, then I can use this variable instead of having to change that hard-coded name in my code or anything like that. So that's why I'm using this environmental variable. Node.js allows you to do process.env, and then the environmental variable name, which is usually in all caps. So then I'm going to create a variable for data. And then I talked a little bit about how AWS Lambda is event-driven. So I'm going to get this event passed to my function. So this is my function right here. And I have this event object. And what I'm going to do is I'm going to check the HTTP method of the event. So I'm going to check to see if the HTTP method of the event is post, and if so, I will create a new item in my table. Otherwise, and no matter what I'm going to do is query and get all the data from the database. So data equals await DynamoDB.scan table name set to table name. And I'm going to do .promise on here to make it into a promise. Okay, so I actually can probably delete this right here. What I'm doing is a scan. And so a table scan is going to load all of the items within that table. So in a lot of cases, that's probably a bad idea if you're trying to filter through items or something along those lines. But in this case, I actually do want to get all the items from the table. And so I can do this .scan in order to get that information. You probably, if you were doing this in a larger application, would want to scale this back or paginate or something along those lines, but I don't even have any data in my database yet. So don't really have to worry about scale yet. So the next thing that I'm going to do is I am going to console log this data. That's one of my favorite VS Code tricks, is that you can just write log and then tab and it will write your console log for you. So then within here, I'm going to create a new item. So I'm going to create this object, put item params. And my table name will be my table name. But DynamoDB is looking for table name spelled this way with the uppercase T. So I'll restate that. And then my item. And so my item is going to match that schema that I put in my database. So to refresh, we have an ID, we have a username, and we have a profile pic. So first, my ID, I'm going to create. And so I'm going to use UUID and then .v4, which is a function. You can use v5 or v1 or whatever, doesn't really matter. User name, which is going to be set to the event.body.username. So the event body is going to be kind of like the event body within an event within JavaScript, but it's going to be set within that event body. Profile pic, event.body.profile pic. Awesome. And then the next thing that I need to do is to enable CORS requests, so cross-origin resource sharing, make it so that essentially I can make a request from my front end to run this. So I'm going to comment that in. And then my JSON.stringify is going to take in the data. And I actually forgot to make my query. So now what I need to do is I'll do a try catch here, which I probably should have done for this as well, but demo coding. So my new item is going to be await DynamoDB.put item params, and then we're going to change that into a promise as well. Changing it into a promise will make it so that the stuff below it won't run until that promise resolves. And I'll make it so that it console logs the error right there if something doesn't work according to plan. So to again walk through what I am doing, I am grabbing my table name from my environmental variables, which is done automatically by Amplify. Then I'm going in here and I am checking to see if the HTTP method is post. If so, then I want to create a new item in my database. So what I'm going to do is create this parameters object with the table name. I'm going to create a new item with the UUID, the username from my event body, then my profile pic. And then I'm going to have my new item here. And then once that's done, I'm going to do a scan to get all the items in my table, then console log that data and send it as my response. So we have this request response cycle. I am sending a request for that. Now I want to test this out because I've written a decent amount of code without testing it. And I can go into my event.json and I can create a mock event object. So this is going to be what I want my event to eventually look like. So my HTTP method is going to be put at first, and that's going to fulfill this conditional. So, and here I have the post, actually, I think I did this wrong, but HTTP method, it's looking for that, and then it needs to be post. So I'm going to do post. And then in here, I'm going to do body. That's going to be an object, and it's going to be username, which I'll do a Spittle, and profile pic, which I'll set to like test.com for now. So then I can run amplify mock function. So I want to mock this Lambda function, so I'll do that. And it's going to ask me for the mock event object that I want to use. So this event.json. And it needs to be error instead of error. Gotta love that. Cool. And it's going to not work until I run amplify push for the storage. So I'm going to run amplify push, and that's going to deploy everything that I just did. So all that I need to do to get this on the cloud is run amplify push and then say yes. So this will create my storage in the cloud, my function in the cloud, and my API in the cloud. So the API is that layer that's going to make it so that when I go to /users, it grabs the data that I need. Cool. So it's going to run a little bit. It's going to take a bit. So if anybody has any questions, this would be an awesome time to ask them. So I answered this one already. We'll talk a little bit more about GraphQL and AppSync in the future too. And then another question is AWS S3 also a server full service? And I would say that you don't really need to manage the server yourself. Like you need to do some configuration of who has access, but outside of that, you don't need to add additional servers or anything like that. So I guess it would fit in the serverless model, but I would say that the line doesn't necessarily matter too much for something like that. And then how does Amplify work with different environments? So what you can do is you can create a new Git branch and then run Amplify init, and that will create another environment at that branch. You can also do Amplify checkout environment. So similar to a Git-based model, you can kind of see that over and over again with Amplify, whereas Amplify pull to pull things from the cloud, Amplify push to deploy things to the cloud, Amplify checkout to check out different environments. So it works really well with those different environments and has support for that. Cool. I'm going to answer a couple more questions. We'll have more deployment sessions like this coming up too. So if you have any questions during those, please let me know. I know I'm giving you a ton of information, so would love to hear that. I wish it played music while it was going, while I was deploying. Yeah, so behind the scenes, this is doing all the cloud resource provisioning for you. Ooh, somebody asked what color theme I'm using for VS Code, and I am using a Fairy Floss, which is my absolute favorite one. And I actually have a keyboard that matches it, which I think is really fun as well. So Fairy Floss is what I'm using. I do change between this and Dracula, which is my other favorite one, or Darkula, something like that. And then another question, how would this Amplify workflow be different if you weren't using React? And so the only thing that would be a little bit different is if integrate this into my front end with React, there are some user interface components that I can use, and we'll use some of those down the road in this demo. So that might change a little bit, but overall, it's going to look really similar. And if you're using Vue or Angular, there are components for that as well. So it would look pretty similar. It's just going to be Vue code instead of React, for example. Cool. So now we're deployed, and I'm going to run amplify mock function again. And this time you can see that it worked. So right now I have one item test.com with the username A Spittle. And so if I kept running that, it would keep creating more and more people in my database, all A Spittle and test.com until I change this. And then if I change the HTTP method to get, then I can mock this again, but it won't add a new person to my database. So now we've created a REST API. We have a database deployed for it as well. The next thing that I'm going to do is integrate this into my front end. So I'm going to go into my create user JS right here. And what I'm going to do is I am going to say const data equals await API.post. Okay, so there is the client side libraries for AWS Amplify. So AWS Amplify in general is for JavaScript. There's also iOS libraries and Android and Flutter. So if you want mobile, there's that as well. But AWS Amplify is the node library for front ends with AWS Amplify. So it has API. We're going to use storage and DataStore down the road. So I have those imported already, so I don't forget to do that because live coding gremlins always get to me. But I'm going to do API.post. So API.post is going to make a post request to my API. Then I have to give the name of the API, which is user profiles. User profiles. There. I can type, I promise. And then it's going to be to the user's endpoint. And then I need to pass the body of the request. So profile pic maybe test.com again. And then we're going to do name, which is set to Blair. And I could definitely hook this up to my form as well, so that I'm using my username from my form and my profile pic from my form. I could very easily do that as well. I just want to make the demo as quick as possible since we're going to be redoing it a bunch of times. Okay, so let's test this out. This is going to fire whenever I submit here. So if I do create, user profiles does not exist. Should I call it something else? User profiles. User profiles. Do I need to refresh this? Oh, you know what? The other thing that I did not do was configure Amplify. So I need to go into my index.js, and in here I need to configure Amplify for my project. So if I comment this in, I'm going to import Amplify from AWS Amplify, and I'm going to import AWS config from this AWS exports. Again, this AWS exports has my paths to my API and things like that. So I'm going to then run Amplify configure on that. So I forgot to do that. That's probably my problem. And it's looking for models. What file is this in? Need to comment that out. And then timeline.js, commenting code out. Okay. There we go. So now I'm going to click create. And fingers crossed, it's going to work. So now you can see that I have a new item created. My profile pic, that's test.com. Why does this just have the ID? Did I do this wrong? Most likely did. Is it this? Nope. Well, I did something. I messed something up, but in theory, it should be creating my new user profiles whenever I click the create. Most likely just mess something up. Oh, wait, you know what it is? I'm doing name instead of username. Let me see. Maybe not. Doing something wrong. That's okay. This is essentially the process that you would take to connect it to your front end. Okay, so now we've created a REST API, and I'm now going to tear this down. So I'll add this to get. So that you all can check this out afterwards. Okay, so now there should be a REST API branch. What I'm going to do is I am going to run Amplify delete. So Amplify delete is going to deprovision all of those cloud resources that I created. So I created all of those, the database in the cloud, I created the API in the cloud, I created the function in the cloud. And so now I want to delete all of those. It's an important thing when you're learning to take these things down once you create them. It probably will not charge you very much, but just in case, it's a good idea to tear things down when you're done. So Amplify delete. Now I get to go back to my slides and talk through more. So we created a REST API. That's what that would look like. There is also a GraphQL API. So a GraphQL API will allow you to send all queries to that GraphQL server. So no more having to rewrite the backend endpoint whenever you change something. So if I wanted to change something with my backend within that Lambda function, I would need to tweak my code and then run Amplify push to redeploy it. Not a huge amount of work, but you can see as this scales, it would become more and more work to keep changing that backend code whenever I want to do something. So GraphQL is here for solving that problem. So no more having to create new endpoints. You can just tweak the GraphQL query to get different data back. And so we're going to use AppSync. So AWS AppSync is a managed GraphQL API service, also serverless. So we're going to be able to use this. It creates a DynamoDB database behind the scenes, but we don't even have to manage it like we did before, where we were creating the columns and all that. We'll write GraphQL schema code, push that, and then be able to interact with it within our code. So let's build a GraphQL API now. So we're still deleting. So I have some questions that I can answer here. So how would we add additional columns to our database using Amplify beyond just username and profile pic? So you could keep adding them like we did before. So when we initialized the database, we added in 3 columns. You could have added more there as well. But the other thing that you can do is you can do Amplify update storage, for example, in order to go back and change things. You can also use the console for that service. So if you want to use the DynamoDB console to work on your DynamoDB database, you can do that as well. So lots of different options. Now we're going to do the GraphQL API. And I would say it's even easier to add things through this. So I am going to need to this is fun. Since I ran Amplify delete, I'm in no man's land in my shell. So let me move this. Okay, so I'm going to need to rerun Amplify init because I ran Amplify delete. So I tore everything down. There's no cloud resources left. So I'm going to run Amplify init again. And that will initialize Amplify for my project. And I will use the default and my AWS profile. So that will run for a couple of seconds to recreate a new environment for me. Yeah, so somebody asked, I'm guessing Amplify is using CloudFormation and thus all the provisioning config is stored in some bucket on S3, right? And so yes, you can actually see the CloudFormation code that was written as well. So if you go through the Amplify directory that was generated for you, you can look through there and see all the stuff that's generated for you. Cool. And again, keep coming with those questions because we're deploying more things. And as we deploy, I have more time for questions. Another question, is there any additional cost to using Amplify, or is it the same cost as using just DynamoDB Lambda API gateway? It's the same price as doing it manually. Amplify does not charge you anything itself. It's just the charges that you would get for using the underlying services. Again, I need like the Jeopardy music or something while this is running. Let me check Twitter and see if there's any questions coming in there too. This is definitely taking longer than it normally does. It knows that I'm in a demo. So for the GraphQL API, what we're going to be doing is we're going to be adding in a schema, and then we're going to walk through that. So I can actually start walking through it because I've got it typed out. I'm cheating a little bit. This one I'm going to copy and paste in because it would take too long to type manually. So we're going to have a couple different models within this. Wait, let me see. Okay, so this is a diagram of the data that we're going to be created. So what we're going to have is a timeline item. So this is going to be either a video or an image or something along those lines for Instagram. And then each item is going to have one content. So each timeline item will have a piece of content associated with it, and that will be the actual image or the video or whatever is attached to that. And then the next one is that each timeline item will have an author. So it will have a user that created that item. So just like any social media platform, Instagram has users, and then those users create posts. And so each timeline item will belong to a user. And then the same thing with comments. So each comment will have an author associated with it. And then my timeline item will have comments associated with it as well. So each timeline item can have multiple comments from different users. So that's a little bit about the schema that we're going to be creating. Okay, I'm rerunning this. It should not take this long. And to walk through the GraphQL code that we're going to be using, we are going to be first creating what's called an enum. So an enum is a data type that just allows you to have different potential values for a field. So it's almost like a custom field. So instead of just doing true, false for video or an image, we'll do an image or a video. Then we will have content and our timeline item. So let's start with that timeline item. So the timeline item is going to have an ID, and this exclamation mark next to it means that that field is mandatory within GraphQL. So each one of my timeline items needs to have an ID. This time though, Amplify will generate it instead of us having to use that like UUID function. Then each one's going to have a description. Each one will have an author. And so you can see that a connection was generated as well. So this connection is going to connect to the user. Then we have a post time, which is going to be a date time field, and content, which is going to relate to this content model here. And then comments. Since these are one-to-one, the relationships look like this. But if you have an array, so this will be an array of comments here, it'll be a connection that looks like this. There's a key name and then the fields that are connected. So our timeline item will have multiple comments. And so that looks like that. And then you can also see that this has some rules associated with it. So it has an @ model. @ model says that this is being stored in the database instead of just being a GraphQL model that's not associated with actual data in our app. You can do something like that with GraphQL, or maybe it hooks up to another API or something like that. But in here, the @ model means that this data is getting stored in the database. In addition, we have authentication rules. So you can have different authentication rules. You can even have multiple of these. So this one is saying that it's allowing public. So it's allowing anybody to do anything to this timeline item. You could also make it so that, for example, only the owner can edit it or something along those lines. So that will make it so that only the user that created the timeline item can work with that thing. But for now, this will be a totally public API. Okay, finally ran Amplify add API. This will be a GraphQL API, Ampligram, API key that will keep it public. I'm just going to do enter and enter. You can choose a different timeline for that, but we'll just do 7 days. Nothing advanced. I do not have a schema yet. So it will ask me if I want to generate a basic one. So I'll do the one-to-many. Yes, I want to update it now, which will just open it in my text editor. And so I have this file here, and I'm going to copy and paste what I showed you all into here. I can definitely walk through more of this GraphQL schema if anybody's interested. I'm going to run Amplify push to deploy this. Oop, I forgot a closing brace. There we go. Okay, somebody asked, why did you not store a list of timeline items to the user object to represent the items that they have written? And the reason for that, for me, is just the access pattern. So what I'm going to be doing is I'm going to be creating a query to create all my timeline items. And then from that timeline item, I will access the user. But if I were instead to be creating a user profile that has all of the timeline items, maybe I would want to reverse the relationship or even make it so that that relationship goes in both directions. So I could do any of the above there. So yeah, it's really just thinking about access patterns. How am I going to use this data, and then modeling your data to match that? But you can very much do multiple access patterns as well and optimize for that. So now I'm deploying this, I'm pushing it to the cloud. So this is going to create that DynamoDB database for me. It's going to provision a GraphQL API within AppSync as well. And the AppSync console is pretty cool too. You can go in there and like run these GraphQL queries to test them out within there. So if that's something that you want to do, you can do that too. And somebody asked, can you run both a GraphQL and REST API side by side with Amplify? And yes, definitely, you could do that if you wanted to. If anybody has any ideas for that, I would love to hear it. I was trying to figure out what kind of demo I could do that would allow me to both create a GraphQL and a REST API. And I was like, not creative enough. So if anybody has ideas, I'd love to hear them. Oh, cool. Somebody asked that so much of this is new and so many moving parts. What was particularly challenging for you to get your head around? Oh, so much of it, like so much of this is years and years of built up knowledge, but even the serverless architecture and moving to that instead of doing like a full server backend API with Ruby on Rails or Django or whatever, that was a big learning curve and trying to figure that out. But even just the concepts here of all this logging. Somebody also asked about cloud formation. So I wanted to show that real quick. It hasn't. Yeah, so all of this is actually generated. There's the parameters JSON. There's the schema.graphql, which we created too. There's the configuration information about the API key in here. So all this is generated. More will be generated as we deploy too. And so the other thing is that this GraphQL directory pops up. And so this has information about the mutations, the queries, the schema, and the subscriptions. So subscriptions allow you to build a WebSocket connection to your models. So if you want to have live updating data that keeps pulling the data, you keep getting pinged whenever something changes, you can do a subscription. That's a great option. Mutations are to change data. So you can use mutations to update things. And then queries are to get data. So if you want to get a user or whatever. So this is what the queries look like. So for example, to get a user, here's list users here. So list users, you can pass filter parameters so that you only get some of those users. So you can get a limit so that you only get a certain number back. And then a next token. So this is if you want to do pagination. So if you want to only get 10 at a time or something like that, you can do the next token there. And then you can grab all the items, the ID, the alias, the email, the created at, the updated at. If you didn't need all of this information, you could delete them and get less information. And that's kind of the beauty of GraphQL. This is the get timeline item too. If you see this, it has all the information nested within it. So it gets the author for each timeline item, the post time, the content, the comments, the created at and updated at. So that one has all the data right there. So now that this is deployed, I'm going to use it within my app. So I'm going to go to, again, the create user here. And instead of doing API.post, I'm going to refactor this so that it has my queries. So I'm going to go into here and instead of doing API.post, I'm going to do API.GraphQL. And API.GraphQL is first going to take the query. And the query that I'm going to use is create user. From GraphQL. Mutations. So I've got this create user mutation within here. And mutation just means that it changes something. So it's a query to create a new user. So here we have to pass in the input, which is going to have the username and the email. So we'll do that. So we pass variables to our GraphQL queries. So here, anything that goes in here is going to, or anything that goes in here is going to be a variable that we can pass to this mutation. And so it's looking for input as one of the variables. And so I'll do input right here in order to match that variable name. I'll do alias, which is set to a spit, and email, which is set to hello@goodbye.com or whatever. So my user looks a little different than when I did it within DynamoDB. Okay, so this time we will try the same thing out. I will rerun my server, which I think crashed. And somebody asked, were the queries created based on the schema? Can we manually create custom queries with limited fields in JSON? Yeah, for sure. So the schema or the queries are automatically generated based off of our schema. So they'll auto generate whenever you change anything within your schema.graphql. So anytime I change anything within this and push, it'll ask me if I want to regenerate my queries. If I say yes, it'll regenerate them for me. But you can also create custom queries if you want. And so all that I do is just create a file with a different name. So like custom queries.js or something along those lines, and create your custom queries within that file, and it won't be overwritten. So the queries and mutations file will be overwritten every time I amplify push, but otherwise, if I create any other files, they won't be overwritten. So that's what I do. The other thing that you can do is you can write your GraphQL queries in line too. So for example, within here, instead of using create user, which is my imported mutation, I could write my mutation as a string right here as well, and that would also work. Okay, let's try this out. Cool, so I ran create and it created a user with an email, an ID, and updated that and created that and my alias. So that worked pretty well. And then if I wanted to do a query to get all of them instead, I'll change this to queries. I'll import my list users and I'll just run that. So data, list users, items, and then my actual item. So that's how I would get them. So now we've created a REST API and a GraphQL API. We're moving at lightning speed here. And I'm also going to talk about some other things. Let me open my slides back up. So containers, which we're not going to go too deep on, but containers allow you to run code on multiple machines in the same way. So there's no more, it works on my computer, but it doesn't work on anybody else's computer, or it doesn't work deployed. I think we've all been there as developers, especially a couple of years ago. I feel like this has maybe resolved itself recently, but containers allow you to run the same exact thing on both a development machine and then in your production environment as well. It also makes deployment a little bit easier, so you don't have to separately install everything every time you create a new server. You'll hear of Docker a lot with containers. That's probably the most used one. So you can create a Docker container. And then there's Kubernetes, which people ask about all the time. And Kubernetes allows containers to talk to each other. So it's for orchestrating those containers. We're not going to go too deep into this, but if you want to, Amplify does enable you to use Fargate serverless containers. So the big use case that I can see for using these instead of a Lambda function would be if you have a long running app. So there's a limit of 15 minutes for a Lambda function to run. So if that task is taking more than 15 minutes, you might want to use a Fargate container instead. Or if you have an existing app backend. So if you have a Django app or a Ruby on Rails app or something like those lines, you could put that in a serverless container and deploy it that way. So that's the main use case that I see for that. Okay, so the next thing that I want to talk about is authentication. So there are things to think about with authentication. So first, I want to define what authentication versus authorization is, and then also talk a little bit about security. So authentication is making sure that the person says they are who they claim to be. So making sure that somebody's password matches what they signed up with as their password. So the person is actually who they're trying to sign in as. And then there's authorization, and authorization allows users to do certain things depending on their roles. So allowing somebody to create a post only if they're signed in, for example, or allowing people to edit things only if they're an admin user. That would be another example. So some basic security rules for authentication is to never, ever, 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 ever store a password in plain text. So never store a user password directly within your database. You'd instead want to use a hashing algorithm in order to hash that. And then you'd always make sure to use that hashing algorithm to check whether the username or the password that they typed in matches the one that's in the database. So you never want to use plain text passwords. It's a big no-no. You also want to make sure that your users use secure passwords, so making sure that they have extra letters, numbers, and things like that, and that they're a certain length, so that they're not just doing like 123 as their password or the word password as their password. Then you also want to think about multi-factor authentication, adding security questions. You want to lock out accounts if they try to sign in too many times, so that you can't do what's called a brute force attack. So a brute force attack would be if somebody tried to type in all the possible permutations of a password, and that would not be a good idea. And so we could lock that account if they tried to do that. You could also try CAPTCHAs. So I always fail the Are You a Robot test that Google are doing right now, where you have to click all the boxes that fit a certain condition. I'll click on all the boxes that have a bike in them or whatever. I find those so hard, but that's another good idea for making sure that a user is actually signed in. So this can help with protecting against common cybersecurity attacks. We're going to use Amazon Cognito, which is going to allow you to add user sign up, sign in and access control to your web and mobile apps quickly and easily. And you can also enable two-factor authentication, social authentication. You can also do those CAPTCHAs and stuff through here as well, if you want to. So what I'm going to do is we are going to start all over again. So I'm going to run amplify delete again, and I'm going to start from another different direction. So we've created a GraphQL API. We've created a REST API. Now we're going to create an online offline API. So this gets back into that distributed systems that we talked about a little bit earlier, where once you have two systems, the device itself and then the database, you have to think about eventual consistency instead of complete consistency. And you also have to think about how you're going to sync the data between the two systems. And so Amplify DataStore helps to address this. So I'm going to go to sandbox.amplifyapp.com and click Get Started. So if you ever want to build a backend without deploying it first or having to even have an AWS account, you can come to this page. And so we launched this last year at reInvent, and we can set up data through this. So I'm going to create a new schema, a blank schema, and add a model. And I'm going to create that same schema that I did before, this time just using this interface instead. So first, I'm going to create the timeline item, which has a description, and then a post time, which will be date time. And then we're going to add another model, which is going to be our content, which is source and type. And then we're going to add in our user, which has username and alias. We're also going to add in comment, which has comment body. So then we're going to add relationships between our data. So our timeline item will have content, and it'll be one-to-one. We'll have a relationship between our user as well. So we'll have one timeline item to one user. Our comment will also have a user. And then our timeline item will have comments. And then I need to have this type be an enum. So I'm going to change this to an enum here and create a new one. So I'll create content type, which is either image or video. Okay, so then you can test this locally in your app. I'm going to go ahead and deploy it. But this gives you instructions for installing the Amplify CLI, for creating a new React app, and for pulling this project down. So again, this follows this Git-like model of push-pull, where you can pull resources down and then push them to the cloud. So I'll pull this down. It gives you that configuration info too. So I'm going to deploy this to AWS. I have an AWS account, thankfully. So I'm going to do ampligram Pluralsight, and then this will deploy. So we've got these the data generated for us, but we're going to add in the full queries this time instead of just doing the users. So what I'm going to do is I need to make sure that I have Amplify configured, which I already did. The next thing that I'm going to do is I'm going to query for all of my timeline data. So in timeline.js, I'm going to add my query to get all my timeline items. Okay, so I'm going to import this. So again, this time DataStore is going to sync the data from my device to my database. So it'll be available offline and online. Behind the scenes, this is using AppSync, so it has a GraphQL API as well. It just wrote the data for me. So if you go to the schema.graphql right within here, you can see that it still generated all of those for us. Like it was deleted before. This was not the same schema that I created. I ran Amplify delete to delete all of that. And then there is this schema file that was generated by Amplify. Then also the models directory was created as well. So it has, I always get the wrong file, but it has TypeScript models for each one of our models. So that's pretty nice that it'll enforce within VS Code that you have certain types. Okay, so now we have our timeline. We queried for all of our data in there. And then within our comments, we're going to go in here to get comments. And this will get the comments for a post. So there's this. And then we'll set our comments to be these post comments. So what I'm doing is making it so that I'm only getting the comments for a post. So instead of getting a list of all of those, I'm just getting some of them. And I'll need to comment this back in as well. And comment that out. And delete this. Okay. So now this admin UI probably is close to deploying. So it's updating right now as we speak. This is going to allow me to create a bunch of data using this interface. So it's creating the data model right now. You can go to manage app content and add the data within here. Something that I noticed as a developer is that a lot of times you have to build the app, but then you also have to build the app for the like people behind the scenes working on the app. So people adding data and all that. And so this kind of does that piece for you. So we're also going to add authentication to this app, and you can configure it here. So you can add email login or phone number, Facebook, multi-factor. You can do email, you can do all of these types of things. Oh, and I have a question about my color theme again. So it is Fairy Floss, which is my favorite theme. Again, I'm totally here for questions. Anytime the types of SSO supported, like SAML or OpenID Connect? That's a good question. So I think you can still customize your authentication if you want. You can go through like Auth0 as a provider if you want. So I think you could probably enable it through something like that. But these are the ones that are default enabled, and so they're the most straightforward ones. Another question, can you write and configure Lambdas that don't use the API gateway in the same repo? I love this, having the code in the same repo and being able to use GitHubs. For example, if I wanted to use a Lambda that uses S3 or SNS triggers and have it on the same code base. Yeah, you could definitely do that as well. You do Amplify add function instead of Amplify add API, and then it wouldn't add API gateway or anything like that. It would just add the Lambda function. And then you could use the AWS SDK to work with whatever. You can even with Amplify add storage for static file storage, you can set up Lambda triggers. So those Lambda triggers will allow you to run a Lambda function based off of some other event. So not necessarily just on API gateway or whatever. So for example, if you want to, when a new user signs up, to run an event based off of that, you can very much do that. So I'm going to save and deploy authentication the default way. Then I'm going to, once that's done, run Amplify pull. So again, totally here for any questions that people have. While this is deploying, we talked a little bit about authentication and we'll enable that, but I also want to talk about storage as well. So storage is needed because you don't want to store things like images or music or static files or PDFs or anything like that in your database. Databases just aren't really built to do that, to handle the massive amount of data that would need to come back for that. In fact, a lot of databases wouldn't even let you do it. So you normally want to add them to something like Amazon S3, which is what we're going to be using, and then store a link to that image within your database instead. Or you can match up the name of the item and store it that way. So we're going to be using Amazon S3, which is for object storage. And the last thing that we're going to do after adding storage is you can also add hosting. I'm not sure if we're going to have time for that because we only have 10 minutes left. And I want to get to any questions that people have too. But Amplify hosting is for front-end hosting. It has CI/CD, so continuous integration and delivery. So you can do Amplify push for your existing system and then automatically redeploy whenever you run git push to your GitHub repository or whatever. Also, we talked a little bit about this with a question earlier, but you can also create different environments. So if you want to have a production and a development and a test, you can do that. You can just change your Git branch and then run Amplify init within that Git branch. And you can do Amplify checkout that environment in order to move to that environment. So that is built in as well. So it's still deploying. But what we're going to do in order to get authentication with our app, I'll move to that. So what we'll do is we just want authentication within create user. So we don't want to make somebody sign in to get to every single page within our application. We just want this one page for people to have to sign in order to do this. So I'm going to use the with authenticator higher order component here. And this one is React specific, but there are similar ones for different frameworks as well. And so with authenticator for this create user component, we'll make it so that people have to log in order to get to this page. And that's still running too. The other thing that I'm going to do is I'm going to add storage. So via S3. So what I'll do is Amplify add storage. And this time it'll be content instead. And it's not going to let me do that until I finish deploying, which I did. Let's see. So I'm going to run Amplify pull. It's going to ask me to log in the browser just to authenticate. I've been having this issue this week. I'm not sure why. I should probably ping some engineers about this. Okay. Let me rerun Amplify pull. And again, if anybody has any questions, please let me know. I'd love to answer them in the last few minutes. Cool. Worked this time. So now I'm going to run Amplify add storage. This time I want to store content. I'll name it this. I'll just use this. And everybody should have access to both auth and guest users. Everybody create, read, delete. Though, again, you want to use this least privilege principle where actually in real life, you'd only want the authenticated users to be able to create, update, and delete. We'd actually do that. And then for anybody to be able to read. And this relates to the last question, but you can add a Lambda trigger for your S3 bucket. We won't do that today, but you can. So I will push that to the cloud. Okay, so now when I create a new user, I want to upload their profile picture to Amazon S3. So their profile picture is stored in the cloud. So we save the new user, but then also we do const file equals await storage dot put profile pic dot name profile pic. So I have the profile pic saved in state. So I'm going to update the name and then the actual image too. And then new user, username, profile pic, which is set to the profile pic.name. So this is going to allow me to get the profile pic that is stored in S3. And I need to import my user model. Import that user model. Awesome. Okay, so that with authenticator higher order component gave me this sign-in form that was like, you need to sign in before anybody can access this. I'm going to create a user account on this page so that I don't have anybody see my actual phone number. Okay, and so that created an account for me, and I have the confirmation code on my phone. So two-factor was enabled. Awesome. Now I can create a new user, hopefully. So I'm going to create an Ali Spittle user, choose a file. Okay, I'll just use this as my profile picture. And, oh no, my region is missing. Do I need to restart this? I probably do. I forgot to say yes to my push. Okay, so somebody asked about the connection on an array of a model type. How many connections is too many for one model type? And I wouldn't say that there's necessarily too many for a model type exactly. I would just say that anytime that you add a connection, it's going to make it so that you essentially have to find the item that's associated with the other one. And so at a really, really hyperscale, trying to use fewer tables will make it so that your queries will be a little bit faster. But That's something to really only think about if you're trying to build the new like Amazon.com or something like that. So if you're building like a app for yourself or for a startup or something like that, it shouldn't matter too much. But if you're trying to build something bigger, I would try to do fewer tables, just so that your access speed's a little bit faster. Thanks all for staying on. I know this has been a really long workshop, but hopefully it's been helpful. It's a lot of information that I'm throwing at you. And again, I'll send out the slides too. So you can have all the information and rewatch the video or check out my code or anything as well. Okay, so now we're updated on the cloud. Localhost 3000, create user. And my new user was created. My profile picture was saved to the cloud. Now we need to go to the user page and actually get our users. So I'm going to copy in this code just for the sake of everybody's time, because I know everybody's probably getting exhausted at this point. But what I'm going to do is I am going to create this function that is get images with links. And so I'm going to loop through all of my user models and await getting their profile pictures. So each one of their profile pictures is stored separately on S3. And so I'm going to await each one being delivered and then push it to a new array and then store that. And so then we're going to have this set of completed users with their profile pictures associated with them. But for some reason, my image is not being loaded in. Why is that? Oops, did I do something silly? I must have. Looks right. Okay, I will put a pause on this for now though and see if anybody has any final questions for me about this. Already getting my calls for after this. Do not disturb doesn't seem to work. Probably have some silly typo somewhere is my guess. It's the fun part with live demos is that I can practice this 50 times and every time it goes right, but then the one time I do it live, it always breaks. So I'm querying for all my users. I'm looping through and getting their image links, their profile pics, their user pics. So somebody asked if you want to see logs for the Lambda function, are those piped to CloudWatch by default? Yes, for sure. So if you go to the AWS console, you can go to Lambda, then you can click on any of these. So I don't know, this is my Ampligram one. And then if you go to monitor and then view logs in CloudWatch, all of them are automatically there for you. Awesome. I'll try to debug this after. I have a completed version of this that works. So I'm not sure what's going on right now, but I'm sure I'm just missing something quick. But thank you all for attending. This was a really fun workshop. Hopefully it wasn't too much that I threw at you. I would love any feedback that people have if you want to send me a direct message or an email. The docs for Amplify are docs.amplify.aws. I am Ali Spittle everywhere. We're also hiring, so if you want to work on this, you can. But thank you so much for coming. This was a lot of fun and lots of really, really